2.2 is on calculators and trig functions of acute angles. So in this lesson, we're going to use calculators to calculate approximate values of trig functions, change between degree minutes and seconds when appropriate, and calculate trig functions using a calculator. So a full circle all the way around is going to be 360 degrees, and which tells us that 1 of 360 would be 1 degree. A degree can be broken down further if it is divided into 60 equal parts. Each part would then be called a minute. So 1/60th of a degree would be a minute. And then a minute can be divided into 60 equal parts as well, and that is called a second. We are mostly going to be working with minutes, but it could be useful to know what the seconds are when working on other trig problems. When we're talking about symbols, we already know that the degree symbol is kind of like a little O. The minute symbol is going to be 1 apostrophe. That represents minutes. I guess let's do that a different color, purple. And then seconds are 2 apostrophes together. So if we were to write this second one out in words, we would put 5 degrees, 27 minutes, and 30 seconds. So that's how you would say it out loud. Now you can add degree minutes together. And when you do that, you are going to add this kind of like you would combine like terms. So we have 48 degrees with 49 minutes, and we are going to add 72 degrees with 26 minutes. So let's start by adding our minutes together. And when we do that, we would get 75 minutes. Then we can add our degrees together. And if we were to do that, we would get 120 degrees. One key point is if you have more than 60 minutes, you need to take out any degrees that you can. So what that means is 75 minutes could also be written as 60 minutes plus 15 minutes. And we know that 60 minutes equals 1 degree. So this is the same as having 1 degree plus 15 minutes. So we can change that, and we would add this 1 to the degrees that we already have, which would make our final answer 121 degrees with 15 minutes. Now, on a test or a quiz, if you are converting between degrees and minutes, you would be expected to simplify the 75 minutes completely. So if you didn't do that, your answer would not be fully completed. We can also subtract working with degree minutes. So for this one, we're going to start with 90 degrees, and we're going to subtract 24 degrees and 14 minutes. And if we don't have any minutes in what we're subtracting from, we can just borrow. So from the 90, we're going to take away 1 degree. So that will leave us with 89 degrees, and that's equal to 60 minutes. Now we can just take 60 minus 14, which will leave us with 46 minutes, and 89 minus 24, which will leave us with 65 degrees. So that's how you can subtract with degrees and minutes. Now, previously and up to this point, we have been working with decimal degrees. So, decimal degrees is, for example, if you had 14.2 degrees, that is an example of a decimal degree. You will be expected to know how to convert between decimal degrees to degree minutes. And to do that, you are simply going to take the decimal part of your number, which this one is 0.25, and you are going to multiply it by 60 minutes. By doing that, you are going to convert it from degrees to minutes, which is where they get 27 degrees plus 15 minutes, making our final answer 27 degrees and 15 minutes. So if we were to go over example 3, we have 41.15 degrees, and we're going to convert this to minutes. If we are following the same steps that were demonstrated for us before, we're going to split up the whole number and the decimal. And then, to convert this to minutes, we're going to multiply the decimal part by 60 minutes. By doing that, we are changing it from degrees to minutes. So we'll take 0.15 times 60, and that will be equal to 9. Making our final answer 41 degrees and 9 minutes. We can also go from degree minutes to decimal degrees. So we're just going to do the opposite of what we did before. So before we multiplied by 60, now we're going to divide by 60. So we're going to start with 10 degrees and 45 minutes. So we're going to separate these, and then we are going to take the 45 and we're going to divide that by 60. And that will convert it to a decimal, so we can write our answer as decimal degrees instead of decimal minutes. Degree minutes, sorry. So we'll have 10 degrees plus 0.75 degrees, because we've now changed it back, which will make our final answer 10.75 degrees. And another thing that we're going to need to know is how to use a calculator to evaluate different values. So for sine, cosine, and tangent, it's pretty straightforward. You're just going to type in exactly what you see. For this one, we're going to do cosine of 37.8. And then we are going to round our answer to 4 decimal points. So always make sure you're reading the directions so you know where to round your answer. So for this one, our answer is going to be 0.7906. Then for sine, again, we're just going to type that into our calculator. So 58.75. And our answer is going to be about 8.8549. Now, looking at your calculator, you're going to notice you're not going to have a key that says secant. But we do know that secant of theta equals 1 over cosine theta. So if we have the secant of 78, that is going to be equal to 1 over cosine of 78. And that is something we can type into our calculators. So we're going to do 1 divided by cosine of 78 degrees. And again, we're going to round to 4 decimal points. So we'll have 4.8097 for our answer on this one. And you would do the same thing for cosecant. You would do 1 over sine. And for cotangent, you would do 1 over tangent. And the next thing you'll need to know how to do is to find angles while using your calculator. For this, to find an angle when given what a trig function equals, we are going to be using our inverse functions. So on your calculator, normally you're going to hit second and then you're going to hit sine, cosine, or tangent. Mine's a little bit different. I just have to hit function. But on your TI-84s, or the ones we have in the classroom, that's what you are going to do. And you use these when you're looking for angles. Our next example wants us to find the acute angle theta, for which tangent of theta equals 3.152. And we're going to round our answer to the nearest tenth of a degree. When you're typing this in, if we're looking for theta, that is going to be equal to the inverse of the function you're using, and then the value that it's equal to is going to go in the parentheses. And that's what you'll type into your calculator to figure out what the angle equals. So we'll have 3.152 in the parentheses. And this angle will be about 72.4 degrees. Then we'll do the same thing if we have sine of A equals something. We'll have A equals the inverse sine of 0.3733. And this inverse function, again, will be giving us an angle measurement, 0.3733. And that will be about 10th of a degree again, so 21.9 degrees. The part that is just a little bit different is when we do our reciprocal functions. For these ones, we have secant of b equals 1.0768. Now, I'm going to show you how to work out this problem if you don't remember the shortcut, and then I'm going to show you the shortcuts. So for this one, we know secant is the same as 1 over cosine of b. And that is equal to 1.0768. So we need to get cosine of b by itself. We're going to cross multiply, and we will get 1 equals 1.0768 times the cosine of b. Then we will divide both sides by 1.0768. Which will lead us to getting cosine by itself. Now this looks just like a problem like example 8 and 9. To find angle B, we are going to use the inverse cosine of 1 over 1.0768. And it is okay to have a fraction inside of the inverse functions. It's most likely always going to be a fraction if you're doing the reciprocal functions. And this one, the angle is about equal to 21.8 degrees. So if you don't remember the shortcuts, that is how you can set up this problem and work your way through it to solve for the angle. For these, if you were doing cosecant of A equals B, that would be the same thing as using the sine, inverse sine, of 1 over B, and that will be your angle. And then, just like we used above, we had secant of A equals a number. And this one we would use our inverse cosine of, again, 1 over that number, and that will give us our angle. Cotangent, we do the same thing. If we had cotangent of A equals B, if we use the inverse of tangent of 1 over b, that will tell us what a equals. So these equations on the right side, this is how you would find an angle. When you are given the reciprocal functions. Knowing that, if we look at example 11, they want us to find the acute angle C for which cotangent C equals 0.0975. And we're going to round to the nearest degree this time. So tangent is the reciprocal function of cotangent. So for this, we're going to start with C equals, and we're going to do the inverse of tangent, just like we have written down here. And then what's going to go in the parentheses is 1 over what that was equal to. In this case, it'll be 1 over 0.0975. This equation will now tell us what angle C is when we type it into our calculators. So for this, we're going to do the inverse tangent of 1 divided by 0.0975. So that'll be 84 degrees, because this one they wanted us to round to the nearest degree. That is the last example for section 7.2. If you have any questions on it, just let me know and I will get back to you.